create a community around that, and foster this input into a strategic research agenda for the Commission. And in terms of what we actually do, concretely, there will be some demonstrators. There's 3 use cases that were mentioned this morning. Both of that. There is this virtual lab sits in this new kind of collaboration by design concept that we're trying to foster. And then finally, obviously, we need to connect with the industry SMEs to meet real demand from real world applications. Just a few words on Edge and dAIEDGE. Again, we think it fits a gap in some of the LOEs that do not address the dAIEDGE and Edge matters, which, if you think about it, take a bit of distance. This is massive proliferation of IoT devices, billions of them. It's only going to increase. There's a surge of the need to develop an application at the edge, not on the cloud, but at the edge, real time on the device, as so be that device. There's the emergence of the smart city concept that is a huge consumer of edge computing, edge application, and generally across all of this is the need for real-time processing, real-time inference, and that comes with a specific set of issues that we're tackling. So for us, edge is basically everything that needs real-time operations and does not relate to a cloud support all the time. And in terms of economic weight, I mean, just for comparison, there's like beautiful graphs about the growth of generative AI, but there's also very significant graphs on the military expansion of edge applications. And the latest research I found was that it's going to triple to 60 plus billion in terms of the edge applications. And that does not include selling NVIDIA chips, by the way. So that's not included. That doesn't include hardware processes. It's effectively accredited to software and integration. So the dAIEDGE technologies that we've investigating and developing in the project, there are kind of three clusters. Some efforts to push beyond state-of-the-art on the commercial side for AI methodologies and software. On the robustness, the efficiency, the consumption, the energy consumption for resource-constrained devices, to make them more efficient, for low power, sparkling neural network also, to enhance the learning communications. All of these are from the relevant specific research consideration that we're examining in various work packages in the project. Then there's hardware infrastructure, which is crucial to grow edge usage. You need specific type of hardware and infrastructure to access the hardware. So that's quite a few effort here on the research side in the project. And finally, what you do with it and how you deploy it and use it, including benchmarking, optimizing, scheduling, and that is also enabled by the development of marketplace and an incubator to access a broader set of stakeholders outside the project. So the type of networks we're growing, developing, expanding in the project will be essentially 3 networks, and today we'll focus a bit more on the virtual lab that we've been asked to talk about more specifically. So aside for now, the virtual lab is basically a new network of nodes operated by partners and outside participants to share and also collaborate in edge matters. The marketplace will join up themselves and users, which is going to be part external, part internal. And then an incubator, which is really to bring in enterprises and finance opportunities to the results and the outputs of the project. So, so why do we need a distributed research lab? What does it bring to the table? It's from a high-level point of view, trying to address a number of issues that are sometimes specific to the edge. So it's not exactly the general, in that sense, we differentiate it from the VRL platform, which has a much broader remit, a much broader ambition. Here, the objective is to provide a decentralized network of resources, of edge resources for researchers, developers that can use without having to effectively replicate the full stack in-house. It comes from the realization that a centralized cloud model it's constrained by a number of cost supply issues and that are ever growing. The cost of it, you see that for AI, it's massive. The idea again is to generate network effects in a network that is easier to scale and to reduce the investment costs for experimentation for people who can't necessarily buy 50 million of GPUs in the market for their own experiments. So it's about sharing to reduce costs and optimize your efforts, improve access, and essentially create flexibility. These are the high-level kind of objectives that reside to the concept of virtual lab. And it is really there to move from the model that is based on the cloud, where there are massive data centers and cloud providers, and then each and every user experimentation user just access and pays and runs their experiment more effectively on the cloud-based solution. Move that to a collaborative network where a user runs or rents a node. It could be a light node or a full node, and effectively based on an API model that is also the same concept of the open platform, which is very versatile and modular, can run and bring some resources and pull and push some resources they own or they wish from node A, node B, or node C in the network. So that again improves availability of resources on demand and then optimize costs for the entire network. And effectively what you end up with, and that's just a very, very good kind of stack for that network that will expand a bit more. We will talk a bit more about the architecture of the VLab. But it's based on a series of containerized services that will be accessible through from the API model. And then and I'll kind of stop here for the introduction of the session, that what we try to achieve over time is kind of network flywheel that where R&D and usage and demand and supply basically meets in a place where all the community by effectively more incentive for the community to use it. And I'll talk a bit about that, but one of the ways to generate that incentive, strap that flywheel is we'll have a light blockchain layer adjacent to the integrated to the lab that will help us develop that incentive layer and also authenticate the trust and incentive, which are the two things that are in a distributed network that cannot rely on one large company taking the trust to all of it. If you have a distributed network, you need trust by design and incentive by design. Otherwise, the network, the collaborative network, cannot be good. So just to break down now, and then we have opportunity now to break it down in part, and then maybe then you can get more interactive. But there will be 3 parts. So what is it? How does it look like in terms of the architecture of it, in terms of nodes and hardware? And we'll talk about that. Then what can we put in there? And then again, we talk about the first POC in that which will have benchmarking, edge benchmarking, not general benchmarking, very specific edge benchmarking. And then I'll talk a bit about the ecosystem and how we see that grow over time.
Thank you, Emma. So, yeah, we start with the first panel, but before, let's then maybe introduce the yeah, implemented so far. So the project is just 1 year old, and but we have a very first beta version of this project for the virtual lab. And the idea is to enhance it during the project life, and yeah, take other partners also on developing the remote nodes. So the figure of, I mean, we have a larger figure later on for the same architecture. It's just to make the link afterwards, so it's here. But just to remind you, the objective of this virtual lab is a research virtual lab. So the idea is to provide access to remote edge devices, which you don't need to have it locally close to your desk to make some experiments with. They will be located remotely, and from your desk, you will be able to access and make some experiments, for example, benchmarking on this device. So because we all know that it's not very easy sometimes to slug a new embedded platform and make it run, and have a lot of installations and browsers that make it difficult. So the idea is to have this digital lab with this embedded platforms remotely accessible by the user. So and the idea is to be able to launch and secure these models, these neural network models apps on these nodes. The remote, the image you see on the top left side, the user beam. Then you have on the right side top orange the server. It can be centralized or distributed, but it will distributed with dispatch the request to the remote nodes. And on the bottom side, you can see, for example, 2 remote nodes that where you have connected different platforms. So you may have Raspberry Pi, you may have NVIDIA, Jetson Orin, you may have a CPU from ST, STM32, or even RISC-based platforms like the GAP9. No? So any kind of device, edge device, that can be accessible. So just to make a bit the baseline for this talk. So we have targets 2 different types of users or end users. One side can be HAI developers, so it can be embedded source developers or integrators. But on the other side, we have also AI developers or HAI developers, which are data scientists, but they do not have experience with edge devices, but they would like to have some feedback from deploying on edge devices. So for this first proof of concept, so we have some features, or we thought about some features of the services that we could provide, that we would like to provide. On one side, we saw the study of deployment, the feasibility study for deployment on the edge devices, so that you have a model that's been trained, and you would like to see if it runs, can be executed on a specific target platform. So you may have experience on it. Then we can use also for the data scientists to develop their own neural network architecture, and they will have some work on that. What will happen if we deploy on a specific platform? So it can help in the network architectural research with hardware in the loop. And the third is benchmarking. It can be in benchmarking of the model itself, or the benchmarking of the app with the pre-processing, post-processing required for the end solution. So for this first talk, we focus on HAI developer, some experience already with the HAI, and we target the model benchmarking of neural networks from these target classes. But the future, I mean, will be the MES, the services and the users that we will cover by this virtual lab will cover more different types of users and services. So here is the main architecture. So yes. Let me go one by one in different building blocks. So on the top right, we see the remote user. So it will be anywhere in the world. And for this remote user, we have a web interface where it will define which kind of touch device we like to deploy on, the model, the trained model that has been already trained on specific framework. Then we like to deploy on the edge device selected. And then it will send this request to the virtual lab server, and this virtual lab server will identify which remote node has to be deployed, and then send it to the node, get back the metrics, for example, for the benchmarking service, so get back to the benchmarking metrics, and then back this to the user with the specific reports on the benchmarking results. Here, for example, we'll see so much details. I make a demo later on if you are interested. So we see the layer per layer benchmarking of the manufacturing settings. So how does it work from the virtual lab server side? So the request that was sent by the user, it arrives here. So this model will be stored in the package registry, and then the variables, the YAML is a file defined to launch different scripts on the selected platform will be the YAML will be generated, and we have a number of targets that are already registered in this virtual lab, and it will make the link to the node where all these files will be executed to generate the code, compile, cross-compile the code, deploy on the target platform, and get the benchmarking platform. So this is what will be done on the remote node. So that is each remote node will have the remote host that will require, that will get this requests from the server. So run some Docker with the different tools required, specific for the platform we are deploying, and then launch the different scripts, generate the binary file that will be executed in the platform, and then the platform will get back the metrics, the results from one benchmarking, and then, as we saw before, back to the server and to the user. So this is a distributed infrastructure that can scale, and that can be can support different nodes with different platform. So with the issues or barriers that we are facing in this HCI world is one side the hardware heterogeneity. So we were talking about the high performance CPUs like the Raspberry Pi with the NVIDIA platforms, with the ARM Cortex-A, okay, the GPUs with some embedded GPUs like the Jetson Molin or Xavier, but we are also targeting low power MCUs, microcontrollers, so like the Cortex-M or the RISC-V platform, but also platforms with accelerators, machine learning accelerators from the researchers or also that are already in the market. So that is one of the first barriers. So there is heterogeneity, the type of platform that we would like to cover. This platform, we also have different operating system support. So some platforms with Linux, some platforms with real-time operating system, other operating system, bare metal. So we have basically also supported OS, and also you can select different runtimes. We can use vendor agnostic runtimes, or runtime, there's a flow light, or light micro, which are vendor agnostic, but also we have proprietary solutions for SDI, for the ST platform, or also the platform. So we see here there are a lot of diversity on times of hardware for operating system support for runtime. But our VLab has to support all these edge and details forward. So at the edge or gateway level, at the device or mobile level, but also on the sensor level. So there are some sensor plates, they already have their own accelerator inside, and we like also to be able to support this kind of sensor with accelerators attached to the remote node to benchmark the information. Our VLab has to be scalable, so it should be easy to integrate nodes, and also be able to manage distributed way these nodes. So, for example, if we want to make a distributed inference, same time nodes, but multiple nodes, so we can then start and balance the load from the different nodes which are available. The workflow that we propose for this virtual lab to support this node is just import the model, generate the code with specific for the target platform, just compile the code, generate the binary, which will be deployed on the platform, and then discrete inference extracted back to the. So then here are the questions that I open to the audience. This is from our view, what we've done so far, but we like to collect your feedback, which are the barriers we consider which are important for you, or the drawbacks that you see in this area of HAI. You have experience with it. And then regarding these barriers, which are the solutions that may overcome these barriers. And also regarding hardware platform, if you see any specific hardware platform you like to support, or other than the ones that have been listed before. So I open discussion with you for this panel now.
Yeah, we have a small audience, so it can be very full. I don't know who is in the room is deep into dAIEDGE or Edge, but anyway, it's we gather any kind of comment or reaction.
We can start from the end maybe, and then we go around.
So how you are organized.
So we have a discussion about the AI, how we will it, and we also have a discussion about the class of AI, how we can actually make solution for we can test. This whole process is very interesting. And so I can let make sure that I understand, but we can about one thing that we can be users. We got a picture lab.
Yes.
If we want to have an experiment, we can use it somehow. Instead of buying devices for our own, we can run it. But we can also be a node on the system as well if we want.
If you want to be a
By providing some hardware, installing the node software.
Exactly. So on one side, you can be a user for the CC, you have a web interface, and then you will just put your inputs, and then you will get the results. Now for the research content benchmarking results, it means other services. But then if you want to provide to be an owner of the remote host, because you have a platform that you would like the others to use and also get somehow feedback from your side. So you need to provide an infrastructure. So we will provide guidelines how to create it, so because it's very standard way of, it's not implementation done by yourself, but we will provide the way for the APIs for connecting to this. Then we will provide so different tooling for the specific platform, so specific source compiler for creating binary for your this we will provide it for Docker, and then we will provide the runtime so it can be installed in the platform, and we will provide the drivers to access the platform. This all is Docker, so that will be the conventional history, and it will be deployed once someone wants to that. This is on one side, and on the other side, the scripts required to launch all these stuff required for creating the binary to deploy and to getting back to the results.
Devices that have this already. How do you envision this happen? We should have very devices connected to our host there.
I mean, depends on, I mean, I can imagine a research lab with his own hardware platform with the system on it. They will plug this platform to the remote host, so to make it accessible from outside. And from your side, if you have some vendor specific platforms, you can also do the work. I mean, if the remote owner decides which platforms we would like to plug. For the moment, we make the experiments with Raspberry Pi, we have the SPM32, we have the NVIDIA platform, and we have different platforms, MCUs and NPUs.
And the idea is that this is fully automated for the remote user.
Yes, that's fine.
So at some point we run an experiment that we won't be there.
Exactly.
So we can connect them.
The user is just requires and then back some minutes later so we get the results. And the idea is to make you know, for example, in today, it's a platform where people publish the results from this market. So it can also be an add-on to this platform. So because we are sure that all the experiments will be run in the same device, so it will be more transparent because you know that installation will be the same at this node. So this is so stuff by this time somehow, because if you run experiment on this node, everybody who run this node will get the results and will be comparable. So we propose as interface, user interface, the possibility to compare results. Compare results with different same model, different platforms, same model with different runtimes, make all the comparisons which are relevant for HCI. Because I mean, we need to also specify when we talk about benchmarking, it's not only software benchmarking, it's not only accuracy, it's also hardware metrics, meaning latency, memory occupancy, meaning CPU load, so on. These are all metrics which are very relevant for HCI, because at the end of the day, it will make it feasible or not the real-time constraints in the HCI side.
And I guess energy consumption.
Energy consumption, yes, for sure. Yeah, the problem is not, we do not have always platforms that provide this metrics. So either we will find ways to require for the site.
As the bigger with I had one lunch with Jean-Marc, and after that I understood what edge means. I'm absolutely not on the edge, so I be educated. But I'm not an expert on this. Today I'm wearing two hats. Here I'm on one hand I'm functioning as AI for media, where I was somehow the AI on demand based on so follow like this. And I think that or I expect that technology stack that we're deploying is something developed on both sides and developed in this project as well, and it's not connected to the AI on demand because
I have to maybe just say that this what we saw here before has been developed during the dAIEDGE. It's not related to what was done in the past. Okay. For the moment, we are targeting benchmarking of models, and we use vendor agnostic runtime for vendor specific, and all the let's say scripts that are developed so support the it's not related to both apps. But the AI asset pipeline, which is done by the AI developer on its own, this can be linked. Maybe you want to train the model, optimize the model to have something that can be deployed and get the feedback. Yes, this we could then merge to the workload that we are deploying.
It's deeply related, and also there's always been this objective to be interoperable with the AI platform.
Yes.
Now we all know that it's been a bit of it's a long story because the AI platform has changed its requirements. It's also it's shaped quite a bit, and then also we're evolved. So, but there is this objective to always try to keep the thread of interoperability with the AI platform, whatever shape it may be, right? And so, and in the project we have this objective also to connect with it. And then the way you could think about it is that this could be a specialist external module to a broader AI on-demand platform. That's the way I think from a high level you can think about it. It's not trying to be another AI on-demand platform. It does AI on-demand, but for very specific services and functionalities. And my understanding of the AI platform is in search of external content and services to grow. And it's designed as an open architecture with API. So knowing all of that, we believe, and to discuss with Martin from the on-demand platform and Gabriel this morning, it's a good complementary effort.
I would not say that it's a topic that's strongly connected to the existing. Something this is where my second head comes in. I'm getting to coordinator of Deploy AI project, just started this year. And there we are building commercial marketplace system targeting industry and buyers. First, we are integrating into this project first services topics. But I think you're coming to step one when I talk about your target audience. Somehow you want to make this available to your target audience, and maybe this might cost money and maybe that's some system where you can put it on. And this would be a very nice use case for integration.
Yeah.
We will deploy AI. We deploy AI.
But
Yeah, I mean, it's a new project. We don't quite, we have some very early discussion with them, but absolutely. Any platform that needs specialist content that can be replicated and that is trustworthy and it would be welcome. With the caveat that this is today more of an experimentation, right? It's not fully baked, hyper locked enterprise grade
Not a product.
product.
okay, maybe you're
Okay.
going.
We need more than dAIEDGE funding, very complete, to get to plugging it, and then some large telecom companies start pinging 1,000 times a day. Ideally, it could be the port to get there, but we need something to build that the government and federal government.
But that's a good story that can be told. Because the Commission wants to integrate all the service offerings from
Yeah.
One marketplace platform.
Yeah, the plugin is quite easy. I mean, you have a mobile, you have a friend, so you just send it to our real app server and it's done. We have to make it more robust because you don't have to back something that's well, for example, or if it doesn't fit with the target that you are targeting, because we may experiment with large models which don't fit our small models and so on. But yes, right, the interface is fine. That's how to
Yeah, and maybe the day where we get a little bit further and then make a presentation to the deploy AI team, so discovery, right, to understand what we're doing. Then we're going to do that for AI for Europe, but we should surely do it also for deploy AI because it's the same.
Sure, we did that, yes, a couple of times and then.
The deploy AI is a deploy is part of the agreement.
Oh, okay. This is a project of AI. Where has started this year, January, I think, for 4 years. And as AI for Europe started supporting research, Where is targeting industry SMEs and public services. And make all the developments and service offerings that have been developed, all of our subjects, commercially available. But therefore, the services need to be stable, and somebody pays money for a service. So make sure that the service is running and working, and there's a problem where you can borrow the service is not running. That will bring this to an enterprise level of integration.
But if I may ask, is the objective at a layer on top of the existing AI on demand platform that is more like a commercial enterprise grade layer to deliver, or also to go lower and then develop also a platform? That's what I'm not 100% sure. I don't.
Yeah, I made a proposal to the organizers of this conference to have a prayer. So that we did not even have our own branding. So the idea is to have first with an enterprise application, they can all procure of services, whatever services are offered. Then integrate those services. Among them, there will be access to European LLMs. There will be access to HPC infrastructure. And there will be access to an AI builder instance that has some of the models on board that are viable for commercial operations. And after that, we're going to figure out what's next. So we start with first MVP, and models.
But I never saw, not in 2 years, but 5 years, so who's gonna maintain it? Because it's something that we need to sort of think on it. I mean, now we're developing it, we are supporting more and more platforms, so mostly from our social partners that can be used from external users. But in the future, who's gonna maintain it? Because everything needs to be maintained somehow. Say that's
In my naive view of things, right? We're building a specific set of services or assets with the dAIEDGE, right? Along. And then this broader trend for AI on demand, which has AI for Europe and for AI. And I would expect, right, that I hope it's the case, that these two projects will create a sustainable model that the specialist effort like us can plug in and access.
What VRL does never been done before in all these projects. We are founding a legal entity and will be running platform commercial from the future that will be in charge of being commercially successful. Because this service offering shall not be funded by your money forever.
Yes.
It must be commercially successful at one point in time. And then for the operations, you do have this. For the technical support of all the components of the arrangements, because projects are contributing to the system software stack, and there are no developers that are backing this software stack. We will trouble. So thinking about open source community that's backing the system or whatever is very good.
Okay. Interesting. Okay, definitely let's
I don't want to hijack.
the objective here today is to create synergies, and that is to me to us a very important synergy. That's the building synergy that I can see for this lab to scale this AI for Europe and for AI. Otherwise it will have to be a third privately funded effort, but that would fit within the roadmap.
But it fits in the 4 billion euros, I think. So we all have some goals that are especially with the button for it's for a light change, but I saw another light.
So just
we are all doing well.
But we should definitely get a follow up with you guys and Ganesh that Joaquin so again.
Regarding this, there's no time pressure at the moment. We have to go on work. We have to do the homework.
Yes.
Okay, thank you. So let's move on. The side that you have any specific work on.
Yeah, I have a question. So first of all, I would share a more senior researcher at CNR. So I'm more on the algorithmic theoretical side of the edge AI. But my question is, would users of the virtual lab to access edge devices in a network of edge devices? So can I tell edge devices to take each other and out?
So this, there is another thread, and we like to add this distribution matching of algorithms. We are not so far, just now there's a discussion, but the idea is to also support this distributed dispatching. How it could be done? Mostly, I will start with homogeneous and distributed dispatching on same type of nodes, and then maybe more theoretically can dispatch depending on the load, but on different devices. We don't know exactly because we need to cover also the security aspect, the trust, the blockchain, and there are many things to be integrated. So it's good to have representative partners, but sometimes it takes time to integrate the technologies together.
For people who like fully decentralized AI, it would be critical also to be able to force a specific topology on the nodes. So not that there is a complete graph, so you have to make nodes. The one graph, maybe you want to start to college or something else, but it should be like user input prototype.
Yes, the thing is, just we think on autonomous system, and I understand that an autonomous system is running its own algorithm most of the time. So maybe you have the card you can then use, and then we distribute it at the lower. But we do not have so many cases where you need to have a network of other platforms where you will distribute your intelligence. So it will be more concentrated on a single one. Okay. So we have to make sure that the use case makes sense. I don't know. But yeah, we are open to this input. So as part of the resources out there, different kind of things. Yeah, thank you. Yes.
No.
Any question? Yeah, question?
Yes. Is it open to other countries?
The idea is to make the value of other partners. For the moment, we are in the very early versions, but we are going to the public as soon as
It's only for.
it's only for inference. We on device only, we want also to the but on device only something also that makes sense. They develop real world applications so that you can have the facility to them by themselves. But we like to open it to every kind of system. More than but we go in the website and we announce version or any feature that's in the system.
See when the first release will be available.
What's the grant agreement?
Agreement is quite, it's not tomorrow for the deliverable. I think it's.
No, the implementation starts in September 2024. We are in advance, but we are doing the implementation should start only on the
Actually, some of the projects at the end of the project, which is now more than 2 years. So, of course, they can.
but on the side, we will be advanced so that we can get feedback and improve it, because if we have the feedback of the project, then we want for improvements afterwards.
So the lightweight version with streamlined features could be relatively within a few months. But then the full demonstrator for the lab, we try to make it based on very concrete use case with meaningful partners and enough number of devices, so it's meaningful data of this live within month.
How many devices do you have in mind?
We have some the development kits that are available, is supported, but also power providing the home hardware. So it depends on the maturity of the development. So, but I don't know if there is any appearing on that, which maybe not.
5 to 10 different devices.
Again, also we recognize the fact that a fully loaded node would be sometimes a bit difficult for some organization to get off the ground in-house because of commissioning or availability, whatever. So it's likely there will be some partners with a stack node and some with a more modular, lightweight access, not just command line, but it's a bit lighter, getting what they have and offer, for instance, so that they be the categories of access, like very light, modular, and a full stack. A number of partners will do the full stack implementation, which we find with the design of the software, the hardware that is needed to do that.
Thank you. So let's move we are also for the consortium.
I can ask question. One question is so would there be eventually in the long run, there's like one network of many devices or many networks of many devices? So is it going to be one giant network with many edge devices? Or
So what's to define a network?
these devices immediately connected, right? So
Well, there'll be different, again, different nodes
yes,
to a network with different level of access and intensity of participation, if you wish.
Yeah.
Does that make sense?
that would be one network, right?
Yeah.
And then would there be like a specialized network for different application domains? Or there will just the network itself becomes bigger and bigger eventually and different application domain will
Right,
using the same network.
And the idea is a network of nodes.
Yeah.
So that the people can access it from outside, but what we deploy is up to the user to define what we deploy. It's just making the experiment with this platform. Will my network, my application, AI application fit to this specific device? How long it will take to run this device? And these questions can be addressed. But the application on the application side is up to the user to define.
But I think the way to look at this one large integrated division. So there is different nodes with different capabilities rather than more hierarchical.
So you see here, for example, here you see
Yeah.
different nodes. So the bottom, you have two different remote hosts with two nodes each. So each of these nodes of these embedded platforms will be accessible from outside, but can be different types of
Well, because what I'm thinking is that depending on the applications, which networks or devices could be greatly utilized or better optimized, right? Some applications may require
Yes.
one settings, other applications require other settings. Therefore, you have more freedom to optimize application specific, right? On the other side, then you don't have as many, very big networks anymore.
So I think there's also an effort, a task in the project to do related to the virtual lab scheduling and optimizing. So that would not be the first release, but there will be a more research-based threat to what is needed to scale. So I don't think we have the answer today, but there's going to be an investigation of the scaling and optimization.
But this scaling optimization will not be done directly on the edge device, be at home, or it will be on the server side. Because there are different layers in Slack, and so it's applications from scaling applications there.
Well, it's good to think big when we hear is network is completely saturated by massive demand from all the system, but yeah, we need to get ready for that.
But one thing to add maybe is that we framed it a virtual research lab also for that purpose. It's not meant to be a production thing. So we don't expect that many companies will try or want to have it running 24/7. It's more for research lab to in the first step.
Research is
So
slower.
if you do research, then you say, okay, I plan this experiment, I check when it's available, or I put a reservation tag, and then as soon as I have my resources, I can run the experiment. And also because at the project level, we will face a scalability issue, which is not related to the technology, because it scales very well from the technology, but from the budget, from what it goes. So if someone comes and say, oh, I want to try now this with 200 nodes, and someone has to create these nodes with the physical devices. And if the project does not have the budget to just buy whatever the users might need. So we will see how we will scale very slowly, and also the external partners that can join, they can also come up with their own hardware. We hope that this will work, but this is not really under our control, because we cannot say, well, let's buy 2,000 of Raspberry Pi.
No, my question was more beyond the scope of the current project, that whatever the outcomes from this current project eventually will translate to the bigger impact, right? That's the whole. Translate bigger impact. There, one wants to see, let's say a simple example that some of the applications are more compute heavy, some of the applications are more data heavy, right? Then just right amount of data storage and communications will have one kind of optimization needed. In other cases, you may even share the same data across different applications, which is more customized applications. These things will over time be taken care of. I'm also asking the question from the viewpoint of like when we were working with NVIDIA clusters, now not the age anymore, there it was really about they are asking us questions that what kind of applications that we're going to develop. Accordingly, they can optimize so that we can get it cheaper, right? It's going to be economical for us because it will be customized to our applications. At the same time, it will address all the issues that we're going to have. This kind of hardware optimized we're trying to do, right?
Yeah, I mean, but yeah, I mean, if he wants, I mean, not in this project, but later on, so we can make the benchmark in different models, different platforms, and back results automatically, and then the reinforcement learning algorithm that we decide which is the optimum result for the same value of the stuff. This is, I mean, it makes sense. If it makes sense, I will not compare this with the cluster of NVIDIA because it's not the same purpose. But I mean, everything speaks
So
for
the same version.
It's more oriented to deployment, not to training. So that's why data is very important in training and on field. Here is mostly experimental, mostly getting some understanding how to place it. So it's not really the same use case. I understand what you say, it's very useful, but it's not really the same. So,
When it in the second phase, when it becomes something that can scale into the enterprise world, absolutely. That have to be investigated. That would be a good product to have.
Okay, let's maybe move on. The time is gonna-
I mean, I'm from Vision and recognition production. I was interested in this field, but I'm not an expert, so I don't have any smart or specific questions for you.
Computer vision, I think it's for the privacy issue, for example, while collecting data on the parent side, it's sometimes an issue. You have to send data to the cloud to process. So processing it at the edge and then transferring say this is if you have processing process.
Yes.
The vision is
The coordination.
yeah.
I didn't want to interrupt, but yeah, I mean, once that is important, but no, the CSA. Maybe just a very simple question. Let's say, I feel that the edge, putting an AI on the edge is very different, let's say, as a field of research with respect to what the others are doing. And it has a huge, huge potentials also for the strategic independence approach, with respect to, let's say, setting of the cloud and else related to that. For example, how are you connecting and finding it easy to connect with the other networks with respect to this specific research field? Are you able to find some synergies or they're still not really ready or interested or,
the number of people here is
Yeah. We might be the odd one out because we've got this very specific vertical. We definitely interact a lot, have interacted a lot strictly with the on-demand platform. That's the question of. But it's true that we might be under, I mean, I'm actually ask you, how do you think we can expand our visibility vis-a-vis the other networks? What's the best way to achieve that? I mean, we're here already.
Yeah, certainly. I think this was very informative, to present what you're doing. But I probably also invite people to finding out how this works, how actually they can make use of it, how they can contribute with the hardware, for example, with their own capabilities. I don't know, maybe going more in depth to the topic with other researchers.
AI is a really huge domain. I mean, we are with AI, but in the same thing. So that's and that is sometimes difficult to understand the chart of the constraints of the others. But I see that the pipeline, the pipeline starting the data collection, the training, data models, training stuff. So this needs to be done also for AGI. So this is a continuation of the pipeline, which continues with the optimization because we need to fuse the models, and we need to also to make it so it's more in the sense of the data types that we use and other techniques that we can apply so that it fits our hardware. But the first mile, let's say, it can be similar. LLMs, we could do LLM once next to us, but we need to make a lot of work to make it fit to our device.
They need to join this session was the term infrastructure federation. because that's something that's a cross-sectoral challenge space, how to make use of all the infrastructures that we have out there, designed not for massive GPU usage, but there is still a lot of compute out there. And this was the problem before I knew that it's point. Yeah, I see some similarities that were facing and that were facing the other.
We also believe, we believe from a high level that Europe has a chance at edge, but it's going to be very difficult for Europe to compete with the big hyperscalers on the cloud, because we're basically late, right? I mean, that's something that never can erase that even for generative AI, not on edge. And at the same time, the big American houses, they're not too keen to put everything at the edge yet, because that could cannibalize some of the cloud business. So there are some very good reasons why edge as a sector of AI should be promoted aggressively by Europe. I mean, it's good to follow and try to catch up, but it's even better to be the first and invest heavily in something you already to be the first, because you often started long before. And I mean, I can't put something in the boil here, but I love that vision to be upstream, and that's what we're going to possibly put in our strategic, work. Say, go edge.
I think we need more promotion. I think one of the keys problem among the partners is that we promote a little bit more the use cases and the benefits of the edge, and maybe are not everyone's doing cloud LLMs. I think there's a lot of benefit at the edge, because most of the processes that we have these days run at the edge. I mean, all the devices, mobile phones, cars, anything that has some electronics in your house also is at the edge. So there's a lot of potential there that's yet unknown. So that's where we can show.
Can you talk to us about benchmarking at the edge, which is one of the killer app of edge?
But it was very good discussion, because I think it was more important than the actual content here. But this is an example of the first service that we have in the virtual lab, which is benchmarking. I've seen benchmarking more and more coming as a keyword for some services, and maybe it's good to remind ourselves why it is good or is necessary. So these days, I think we have very fast cycles from research to deployment and product. So what people try to do is to have end-to-end workflows so they can quickly test their ideas at the edge, or maybe not at the edge, but in the product side. So that's why benchmarking is very important, because it gives you the feedback that you need to improve. And if you are able to have very automated benchmarks, then you are able to adapt your design much quicker, and then you will be ahead of the curve, because you can get the feedback and modify your design for every customer you have. So that's a little bit why we are focusing on benchmarking. We feel very important, and specifically for the edge, it's very difficult, because it's not as simple as having some Python code in your PC. You need to really, like as India was explaining before, have some workflows so that you can cross-compile, deploy, get the metrics, and that's quite cumbersome. So that's why we are trying to address this topic. And here are some of the barriers and drawbacks that we see. There's a lot of incompatibility, because we have a lot of heterogeneity in the hardware platforms. Also, some of them are hardware specific. So the vendors, they create their own software to deploy on their own hardware. Sometimes it's open, sometimes it's not. So that brings some complexity. There is not really a standard, like in high performance computing, everyone is doing a little bit their own things. There are some works by the IEEE Foundation to standardize things like Bluetooth, but this comes a little bit slower than the actual development of AI, right? So we see certain compatibilities here. Also, the expertise is quite vast, because you can be an expert or not on AI, software, and hardware. And here we have the three things together. So combining someone that knows about all three things is quite difficult. And then, of course, the use case can be different. You can have cloud, edge, distributed, or multimodal, like where you have vision, audio, or signal. So it's quite vast, it's quite difficult. So that's why we're trying to a little bit have some principles so that we can help SMEs, but also some scientists, for example, they don't have the expertise to do this system. Our main idea is to have some sort of workflows that are able to ease the process and be agnostic in a way, so that we can plug in different vendors, different platforms, hardware and software, and compare with the same workflow. So that allows us to be a bit more trustworthy, because we can do with the same workflow different comparisons across vendors, and also we are trying to make it reproducible so people can actually like test it on their own site and then validate that actually works. We like also that it's not only research, but we try to take as much feedback as possible from industry. So actually try to benchmark solutions that have some pre and post processing that sometimes is very, I'm not going to say avoid it, but people don't really care about those things because they're just benchmarking the model, while the actual solution is much more than the model, so pre and post processing that's involved. So one of some of the metrics that we are getting when doing this benchmarking are across different sectors. So we benchmark the metrics from the neural network, like the plots, parameters, the storage. From the hardware side, as I was saying before, we have latency and throughput, but also memory is very important, because maybe the model is not able to fit in the memory, or the bandwidth, because maybe you need to wait more time to load the model the data that comes into the program. Also, the processor load, the temperature, power consumption, or energy consumption is important. And then we can do this across different layers, levels. So we can have like a layer benchmark, or a model benchmark, or the application solution, or even the system. So it's quite complex. You choose maybe there's some trade-offs, so you can choose how you want to go. And then, of course, all of this depends on the application. In terms of classical AI, we have accuracy or error. We could also have some other like sensitivity, specificity, other confusion metrics. And now these days it's much more about text similarity, question answer accuracy, where there's LLMs in the loop. So just a little bit with a small introduction. What is you see really useful in terms of benchmarking the metrics or the hardware, or what is really like you see that we should adopt or add to this virtual lab? It's a little bit there. So if you have, I think you have 10 minutes or 5 minutes.
We have 5 minutes, so even if they
So if you have any comments, you can think that.
on the benchmarking side, if you are the user, which kind of metrics you would like to get.
I'm thinking of one of the USPs we might have, the European values, respect of trustworthiness, and how can you benchmark trustworthiness? Had some discussions, this might be a yes or no decision, if it's trustworthy or not, or can it be somehow random?
I think you need to define what is trustworthiness, because trustworthiness can be understood as ethics, or is something that's reproducible and verifiable. So you need to define that first, and then I think by design you can benchmark something, because by design it is trustworthy or not, because you have a workload that follows a policy, or you need to validate certain quality that you can benchmark in terms of some of those metrics. So we try to get there. Now, what is trustworthy or not is a little bit subjective at the moment.
Yeah, but there are many people working on this. They might help us.
We try to promote that we do trustworthiness, but you can tell us if it is true or not.
The benchmarking is by essence a form of trustworthiness by design. You have a data set that proves the accuracy or lack of thereof, or the efficiency or the lack thereof, and rank of those applications on that. So it's deterministic in a way, right? It's not like a software issue. We create trustworthiness by having a benchmarking protocol. Whether the protocol benchmarking is true, is correct itself, it's another issue. But already you deal with the first derivative of trustworthiness in dAIEDGE, which is this application going to do what I want it to do with the metrics I want it to do on that hardware? It's not an existential question, but it is truthful in that sense.
But maybe we have to also go to the certification. We certify that this node belongs to the lab that has been tested. So we've done that. That's what benchmarking the results that we are providing.
Certification.
So where trustworthiness, and then maybe I'll say a few words to conclude on that third part, which is, sorry if I move on from benchmarking, but it's what do we need more from such a collaborative distributed network? What are the features and the key features and functionalities that are needed, knowing that there's not going to be like a big centralized administrator try to devolve the process to nodes. So you have to look at those networks in a different way. Trustworthiness, how do you affect trustworthiness in a network of nodes? If it's not, a large Microsoft or Google that tells you it's truthful, believe me, then what we're thinking about is the concept of authentication, concept of golden state of record, and we're thinking about also ownership. And what are the means today by design to achieve those three things? Authenticate, prove ownership, and what was the third one? And record the result. It's a blockchain. Why? Because it's basically certified by consensus as opposed to by the big vendor. So we're thinking of bringing a blockchain layer to that network, giving more truthfulness by design, because it's going to be a smart contract established the truthfulness and not a person or persons. So that's the angle we're exploring, to give a bit more autonomy to the network and be able to devolve more of the functionalities to systems as opposed to people. So that's our view of tackling truthfulness by design, not having a committee of smart people decide this is truthful, this is not, but it's truthful by smart contract. So then the problem will be error in the code. So you need to validate that and test it, and so we push the truthfulness to a more deterministic or validation answer. So we're thinking of doing this, having a modular system that not everybody needs to download the full stack, because we know that's going to be onerous. We try to limit, lower the access to resources. So we're not going to start saying you need a big investment to access the network. Add a secure layer through authentication and with a light blockchain implementation, and make it interoperable with AI on demand in order to ensure sustainability. And deploy AI even better if we have features that can reach to private market. So these are the avenues we're thinking about in order to scale that network. And the last, but I keep that still developmental, that with this blockchain layer, we can also create, activate reputational layer, incentivization layer, where effectively you enshrine the usage on the blockchain, and then you can devolve points to those who use the network. And those points in the network, notoriously ownership in the network, point in the network, at some point gain value if the network grows. And it's a positive flywheel I was talking about. So that's still at the tail end of our effort, still more research, but that's something we're thinking about bringing to empower the growth of that distributed network.
Just to follow up, this is not in relation to if the node itself has blind spot or biases, right? If the we're talking about that model that you're thinking about.
Yeah, no, it's not the content of the model. We don't touch that at this point.
So can that be benchmarked too? That when you are benchmarking the accuracy and sensitivity and so on, so forth.
But how do you define the criteria?
So the blind spots, I mean, first of all, you can just to study, of course, those attributes where things more can go wrong, right? Let's say it's simple about gender study, if one particular gender, one particular race, the model is kind of biased towards completely doing the wrong or the bad predictions to begin with. that we can go with not only interpretable or level space, but can be much more fine grained, that where it can go actually wrong in regard to the, let's say, simple comparison of the performance against different attributes, right? Could be analyzed.
So we don't have this capability in-house.
Yeah.
So that will have to be an external validation service. So we're thinking any work, we'll have to list those kind of must-have or good-to-have features, but then we have to define where we can get them, because they're not going to be natively developed by this project, but they could be connected to the network. That's the way we think about it. Whereas some of these features like authentication, that goes across, right? It's more like everywhere. But quality, deep quality item like this, we'll have to source them from an external partner. Okay. But we like to put them into future potential requirements for the network to scale, although we're not going to build them realistically in the scope of the next 2 years.
How do you define the hardware methods? So the running models,
The metrics.
yeah. So you have network metrics, so it's also website. So after you have hardware metrics, you have latency, for example, inventory rate, other patterns. So
Measure it. Measure it.
with it.
Yeah.
Yes, the device.
So it depends. So,
Yes.
you define an equity kind of link between hardware metrics. So if we have used it, it's a super we will compensate.
Yeah.
Because it merge it. I mean, it's you have it, so you have all of it. Doesn't have to use it, but doesn't have to design the better.
Yeah, but for example, you have your models, you can quantify. Smaller, it will be faster, but it will be less. So you will compare, the having able to compare. And try different optimization techniques to your model. And then you will compare the results. You will choose the one that fits better your target.
That's the actual goal, that you can deploy, get the feedback on those metrics, and then redesign the model. With hardware and delivery.
We are not providing the optimization per se, but we are offering the results of any test. No, the information is left to
I mean, in the part that we give us some projects from the organization as well, but at the moment we just offer the virtual lab and the users.
So, for example, for you manage one sort of where you do how do you sort of measure
But for the moment, it just provides back to the user, and the user will create its own algorithm for us. We are not having the link.
For example, we want to use that, for example, I said, if you just wait, how long does it? And because here it's manual.
No, it's automated, but so it doesn't always make sense to go edge with NAS, because NAS is very expensive in a way. So in that sense, you see the cost of predictors that can take some of those metrics automatically. But it's not as accurate as. But NAS by itself is not very accurate either.
And
No, you don't run NAS. You run on the cloud.
Sí, ya está con el
So the model is not a NAS, but they are following the network to get feedback when it happens.
That's proposed by the source methods, and now needs to be tested on the SD.
I see, estimate,
You can do that as well, it's not as accurate, because every hardware is different. You know, like estimate 100% every hardware is different.
Okay, so I think we're close to the end of the session. We spoke about the network, the hardware, some services, some of the future developments. And then in terms of integration, just to give you a visual, we're trying to show that the VLab really is just a part of a kernel way broader. We expect the VLab to be enabling additional services and then future functionalities and then connect to other platforms. We identified the AI demand platform. We're going to add more AI when we know more about the future state of the project. And then we have some bonsai functionalities that are present across the project. And then Prevail is the testing experimentation facility for edge hardware. So we have to investigate how that can, what are the touch points with our VLab, and that will then be some that we investigate for scale partnership with other projects. So yeah, that's kind of where we are. Just want to thank you for your questions and intervention, and don't hesitate to reach out to us if you want any more engagement or questions. We're always happy to. Any of the four of us, we'd be happy to respond. So
I got it.
Yeah.